greatest physicist of all kind. I have a problem here with me on physics. Okay, so it's strictly on electricity. Don't forget to subscribe as you're watching this video, which is very, very important, because subsequent time I keep dropping videos on physics and mathematics. Okay, so it's strictly on electricity. Let me quickly read down the question. Two identical cells, each of EMF 1.5 volts, connected in parallel, have an effective internal resistance R if a current of 0.6 ampere passes through a 2.0 ohms resistors connected across the cell. Calculate the value of R. So in this particular question, we're being asked to look for the internal resistance or internal resistor, which is my small watts R. Okay, so the first thing you need to do on this particular question is to bring out the parameters from the problem, which is very, very important. So solution. Okay, two identical cells, each of EMF. So my EMF is given to me. So my EMF is equals to 1.5 volts. Okay, connected in parallel, have an effective internal resistance R. If a current, that means current is given, my current, which is I, is equals to 0.66 watts ampere, passes through a 2.0 ohms resistor. That is my external resistor, which is given as what? 2.0 ohms. 2.0 ohms. Okay. They now said what? Are connected across the cell. Calculates the value of R. That means my small r is what I'm looking for. It's unknown. My small r is what? Unknown. So with this, I have mark already, bringing out the parameters from the what? From the question. The next thing is I'll now look at the parameters and bind it with the formula. So what is the formula? My I is equals to my E divide by my what? Need to open brackets, my external resistor plus my internal resistor. Okay, so this is the formula for this particular problem. The next thing I need to do, I need to make my internal resistor to stand, which is my small r. How will I do? I'll cross multiply. Okay, so I'll have my what? My I open bracket R plus my small r, close the bracket, is equals to my EMF. Okay, remember I'm looking for my watts, internal resistor, which is my small r. So I'll divide both sides by coefficient of r plus r. Okay, so what will I now have? I'll have my r plus small r is equals to my EMF divide by what? My I. Okay, so the next thing I'll need to do is to move the external resistor to the other side. So my R is equals to my EMF divide by my I minus my external resistor. Okay, so with this, I'm done making my internal resistor to stand. So I'll need to now substitute my parameters into my formula. So my R my small r is equals to, anyway I see my EMF, I'll put my 1.5. 1.5 divide by my current is what? 0.6. 0.6 minus my external resistor is what? 2.0. 2.0. So my small r is equals to 1.5 divided by 0.6. So I'll have my 2.5. Yes, 2.5 minus 2.0. So my r, my small r is equals to 2.5 minus 2.0. I'll have my 0.5 ohms. 0.5 ohms. So this is the what answer to this particular problem given to us. Okay, don't forget to subscribe.